let's get things started by building out the geometry that'll be used to tell the sparse pyro solver what it needs to do. So down here I have the SimGeo section. This is where all of our simulation geometry will happen. Up here is the base geo, and this is where all the models are built. So in the SimGeo, if I go here, we have these object merges. And the first thing that I like to do is isolate the areas that flames are going to spawn. So here I have the logs, I have the embers, and they're merged in. Now the first thing I do before anything else is I think about scale. Because if we fit these logs into a 1 meter by 1 meter scale, then that's going to allow all the default values to make sense for that particular scale. And really, it's just a way of making your life a little bit easier as opposed to guessing what some of these values might be if you're at the small scale. Let's create a box. This is what 1 meter by 1 meter looks like. And what I'm going to do is take this merge and append a transform to that, like so. Template this box. I'll say move centroid to origin, and then I'll scale this up until we fit the box. So this is where we're going to simulate everything. And then once we're done simulating, we need to apply the reverse transform. So let's set that up real fast. Make a copy of this. And what I'll say is invert transformation. And there we go. This is the same exact thing as what we have up there. Now the idea is that we simulate at this scale, and eventually we bring it all down to this scale. If you haven't done so yet, I would recommend checking out Pyro 1, or at least being familiar with the overall workflow when it comes to creating Pyro. I'm going to assume that you already know what that is and go a little bit fast during this particular section. So now we need to create points. On those points, we'll rasterize attributes. This will give us the volumes that need to be used by the solver to allow the sparse pyro solver to think about things. And again, if you don't know anything of what I just said, go ahead and review Pyro 1 because I want to keep things moving. All right. Pyro source. This will give us the points. Do that. Mode, surface scatter. And I'm going to say a particle separation of 0.025. Particle scale, let's set that to 1. And then the attribute that we want to rasterize is this thing called flame. The sparse pyro solver is going to look at this field called flame to determine where flames are. So when I make this attribute, I want it to be called flame. Once I have that, we'll then eventually want to add a bit of noise to these values. So let's say attribute noise right there. And we'll go up here to the top, specify flame, like so. And then eventually we'll want to rasterize this. So volume rasterize attributes right there. Attributes, flame, and then last but not least, a volume visualization so that we can see what we're doing in the viewport. So let's go right there, density field, flame, and then down here as well, we'll say flame. For the density scale, I want to set that to 100, so that's very obvious what's going on. And now we have something. It's not looking right yet, so let's go over here and turn up the resolution. Our particle separation looks fine for right now. On the volume rasterize though, let's say a voxel size of 0.01. And also check on this normalized by clamped coverage. That'll kind of smoothen everything out. Let's change our viewport here to be this icon so that we can see what we're doing. And then in this attribute noise, let's now dial in a noise that breaks up these values. So we're at flame. Let's animate this. Set it to Whirly Cellular. Let's remap the noise so that we're working from 0 to 1. Because this is a scalar value, we're not doing a vector, these two parameters are really the only thing that make a difference. So you don't need to adjust these, but just for good measure, let's just say 0 right there. Well, hold on. There we go. 0, 0. And then for the distribution, I want to say that our noise values are likely to either be 0, which is over here, or 1, and I don't want in-between values. So by doing this, it'll add contrast and it'll make our noise show up more obviously. So now that we have that, let's take our element size and say 0.5. Let's go down here to the roughness, turn that up a little bit. And then for the pulse duration, let's turn it to something faster, so 0.5. And now we have something like this. However, if I go to these point values, you'll notice that we're going past 1. And I don't recommend doing that for the flame field. For the flame field, I try to keep this normalized as much as I can. That means having the values between 0 and 1. So instead of adding to the values, which we can see right here, additive, I want to multiply instead, so that we're starting at 1 and we're bringing that value closer to 0. Now, in our scene view, we can really see what this noise is doing. And that's a lot easier to control. So there we go. Multiplying, we have that. I like adding 2 noises, or at least 2 noises. So maybe this will be our large noise, and we'll make a faster, smaller noise. So we'll call this our small noise right there. And then for this, we'll take the pulse duration, make it lower so the noise moves faster. And then let's go to the roughness, turn this up a little bit, element size 0.15. So then now we have something like this that breaks up the flame volume. And also on this large noise, let's change this to 0.75 on the element size. Okay, so these are just starting values. We're going to alter this here very shortly, but this will work as a general setup to get things going. Let's detach this transform. We'll use that later, but we don't really need that right now. So I'll just set it to the side, create a null, and this will become our flames out. So now that we have that, the next thing to do is to create a DOP.NET. And I'll do that on the SOP level. .NET. Let's call this our PyroSim. Right there. And let's add a sparse pyro solver. Now the sparse pyro solver requires a sparse smoke object as well. So keep that in mind. Smoke object sparse right there. And then let's also create a volume source to source in the volumes. So again, this volume source, much like what you might have seen with any other DOP simulation, this brings things in from SOPs, and it's kind of like filling the smoke object with the information it needs so that that can be delivered to the pyro solver. So now that we have this, I'm going to give myself a little extra tab here. And if you don't have that layout set up, you can just split left and right there, and that'll do the trick. Let's now find the volumes we just made here in SOPs. So we'll go right there. For the volume source, drag that into SOP path. And then we want to create a field here. Our original volume was called flame. Now our target field is also called flame. And for right now, I also want to create another field called temperature. So originally, our volume is called flame. Now I want to assign that to a field called temperature. And just as review, a field is basically a volume that you can use in DOPs. In this case, that's what that is talking about. So just keep that in mind. There's really no difference between this information and this. It's just that in DOPs, we call it a field. Okay, so now that we have that, I'm going to set the operation here to maximum so that we always take the maximum flame value. And then for this temperature, I'm going to set this to something called pole. What pull will do is it'll take a look at the existing voxels in the simulation and pull those values towards the source volume. So if we, let's say, have a value of 50, that means, okay, look at the existing voxels in the simulation and gradually pull them towards a value of 50. Okay, so we don't see anything quite yet. We have this little box right here, but in order to actually see what's going on, let's go to this multi-visualization tab and fill in these fields, because by default, they're not filled in. So density will be our density field. And same with diffuse, go like that. For the emission field, let's say flame, and the color field is also flame. The emission scale, let's set that to 10. And then the last thing to do is to uncheck density, check on multi-field, and then go to the volume source towards the top here and say enlarge fields to contain sources. What that basically means is that if we source in some volumes, we're at the origin right now, but like, let's say you had something up here, it's saying look up there. And just in general, you always want to keep that on whenever you're doing sparse stuff. Okay, so now that we have this, look at that. We have low res fire, and it's amazing. Now, to change the resolution, we can go up here to the voxel size. Let's turn this down to 0.05 and go forward a few frames. Now we're at 32. As you can see, we're starting to get a little bit of a more fine result. Let's try 0.01. And now if I go forward, it's going to take a minute here. But as you can see, we have fire. And it's doing something, which is great. Okay, so one last thing to get us a basic setup, and then I'll slow things down and talk about the details. Let's take whatever this DOP simulation comes up with and recapture that in SOPs so that we can cache it out to disk. So back on the top SOP level here, let's create another geo network and call this our Pyro imports. Color that light green. And in here, I'll use a DOP import fields. The DOP import field just takes fields from a DOP, as it says. Just go over here and drag over the DOP.net like that. And then for the fields, for right now, all we need is flame. Let's just say star smoke. And I believe that'll just take from the smoke object, maybe star smoke star. So anything that contains the word smoke within the object name, that allows us to select the smoke object right there. Now that we have that, we can add one more field. Let's say our density, we'll want some smoke eventually. Same deal here, anything with the keyword smoke. And then one more for right now, velocity. Eventually we'll do motion blur, so we'll take the velocity field, and those three things for right now will do just fine. If I middle mouse, as you can see, we in fact have those fields. If I do a volume visualization right here, I could say density right there, density, and then under the emission tab, flame, flame, emission scale 10. And now, as you can see, we have glorious fire. Now, there's a couple more things before I wrap up this video. Let's now go back to our Pyro source and apply the inverse transform. So take this guy to scale it back down. Let's just Control X to cut. Bring him over here. Now we have our stuff moved back to where it was originally. So we're right here. Let's ghost other objects and also turn off this Pyro source and this Pyro sim. And now, as you can see, we brought it back to the main fire pit like that. File cache. We'll save this out. Let's call this our Pyro sim like that. hipgeo$os.$f4.bgo.sc. Eventually we'll save that out, and then I like creating another file SOP right there, and we could just do a relative reference. So copy parameter, paste relative reference, and we'll say this is our pyro read. And there we go. That is a basic setup in Pyro. Now, we obviously haven't changed any of the main settings. This is just getting the bare bones set up so that now we could start working with Fire, dialing it in. And in the next video, let's start doing exactly that. We'll take a look at the methods in which we're sourcing and get these parameters in a general area that looks decent.